Welcome to the second video of our data-driven project. In the first video, Manuel already discussed the theoretical part of the gMcNemar tool. In this video, I'm going to discuss how to use this tool in SAS. So let's start by reviewing this case study. We're looking at data that was collected in one hospital from 800 cancer patients. These patients received a pain relief therapy. And then the researchers want to know if the patient experienced a different level of pain before and after the treatment. So we had a 5 by 5 contingency table. In the left side, we had the explanatory variables, which is the level of pain. So we had no pain, a little pain, moderate pain, high pain, extreme pain. These observations were taken before the treatment. And then on the first row or column headers, we had the same categories, but these are the response variables, and these observations were took after the treatment. So the way we read this table is like this. For example, the number 25, that means that 25 patients had like a moderate pain before the treatment, but they reported no pain after the treatment. So the next step is to set up the test. We're going to be using the generalized McNemar test because we had a 5 by 5 contingency table. So first of all, we define our null hypothesis, and we're saying that there is no significant difference in the level of pain experienced by patients before and after the pain relief therapy. The significance of the test will be 0.05. The degree of freedom for the generalized McNemar test is k minus 1, where k is the number of levels that we have. In this case, we have 5 levels, so we're expecting a 4 degrees of freedom for the test. And then the decision, if the p-value from this test is less than 0.05, then we're going to reject the null hypothesis. So let's go to SAS right here. The first thing that you need to do is to create a folder. I create a folder right here on the left side. You can see its name, me776. And in the folder, I drop like the macro or the tool. So let's look at the code. This is the code that is inside the tool. But as the user, you only need to should only care about the first 4 lines. And those are like the variables that this macro is going to be taking from your code. So the first one is just the data frame, and then the row number, the column number, and the frequency, which is the count. So let's go back to our code. The first statement right here, I'm just creating a library that's called project inside the folder me776. And then I'm using the data statement to create a data frame that I'm gonna call it pain. And then I'm using the input statement to create the variables R for the number of rows, C for the columns, and then the count for the frequency number. Then I'm using the data lines statement to enter the data in this data frame, which is called pain. So the way we enter the data, it's where we need to enter first the number of the row, the number of the column, and then the frequency. So for the first frequency value, which is 5, that frequency was located in the first row and the first column. For the second frequency value, which is 8, that number was located on the first row and on the second column. And you had to do that until you enter the last number in the contingency table, which is 41. And that was located in the row 5, column 5. The next statement is the percentage in. That statement, we're telling SAS here where the macro file is located. To get the path, you just have to right-click on the macro file, then go to properties, and then right here where it says location, that is the path. You copy that, and then you pasted it in inside the quotation marks. Then the title, that's we're just giving a title to the output of the test. And this is the most important part, line 16, that's where we are invoking the macro. We're using the statement percentage gMcNemar, which is the name of the tool. And then we're passing the name of the variable for the data frame. We are going to pass the variable pain or the data frame, I'm sorry. And then the variables are for the rows, the C for the column, and then the frequency, which is count. And then to run this code, you just highlight this and then click on this icon here. And then here we have the output. We are only interested on the first table. The test statistic is 11.76. The degree of freedom are 4. And then the p-value is 0.19, which is less than 0.05. So we're going to reject the null hypothesis. So if I go back here, because we're rejecting the null hypothesis, the conclusion is that there is a statistical significant difference in the level of pain experienced by patients before and after the treatment. However, we don't know from the test if the patient experienced more or less pain after the treatment, but there is a way to know that, and that's by calculating the percentage. Um, we look first at the patients that didn't show any change in pain. And those are the ones highlighted in yellow, which are going to be the diagonal. If you sum them up, you will get 208. And if you divide that by the sample size, which is 800, then it's 26% of the patients. Then we had the patient that experienced more pain after the treatment. Those are the numbers highlighted in blue. It's just sum them up, that's 247, and that's a total of 31%. And finally, the patients that experience less pain after the treatment are the ones highlighted in green. And if you sum them up, then you get 345, and that's a total of 43%. So the conclusion is that the treatment is successful most of the time when it is applied. And that's because at least 43% of the patients are reporting a reduction in pain after the treatment. So the next step for physicians is probably they will have to focus on the numbers of patients that didn't show any change in pain or those that show more pain after the treatment and probably customize their treatment plan and kind of like tweak these kind of treatment for those patients based on the actual health condition. Finally, we had some conclusions for this gMcNemar tool. As you can see, it's easy to integrate in your code. You just need to pass like 3 variables to the macro, which is the row number, right? The column number and the count. This tool also eliminates the need for using another statistical software like R, so you can compute the generalized uh, tests here in SAS. And then it's also like the output is reliable. This tool has been like tested in different like healthcare studies. And it's also versatile because you can use different like potentiality table size. We use a 5x5, but you can also use a 6x6, 7x7. And then the tool can be used in other like fields or industry, human resources, for example, if you are dealing with training programs and you need to compute the McNemar test to assess the effectiveness of like training programs. Then if you're using SAS, you can use this tool. In the education field as well, you are comparing the success rates of 2 teaching methods, and you are using SAS, then you can also use this tool. So that's the end of the video. I hope you enjoyed it and learned something for this video. Thank you so much.